In this video, we want to learn and work on the hypothesis test on regression model, linear regression model, and simple ones. When we say simple one, it means that we have one regressor or one independent variable that our output is depending on that. As we said, for example, our output is the amount of the greenhouse gases emission, and our variable is that the amount that we will our fossil fuel consumption, the amount that we would consume for the from the fossil fuel. So for the hypothesis test, we have other videos that it talks about the hypothesis on the mean, when we know the variance, hypothesis on mean, when we don't know the variance, hypothesis on variance or standard deviation, and hypothesis on the proportion. We said that we have 4 categories while we are working in statistics, and those 4 categories we learned about the hypothesis there. If you want to watch this video before going further, I would recommend that you go at least watch the first hypothesis test that we have in the playlist, and the name of the video is the hypothesis test on the mean variance is known. In that one we have all of these steps. I described that in details. So we said that we have 8 steps. We are gonna work with the knowing what's the parameter of interest, and at the end, in the 8th step, we will reject the null hypothesis, or we would fail to reject the null hypothesis. So with this one, for the simple linear regression, when we say simple linear regression, we want to write down the model of it first. So I would say y is equal to beta null plus beta 1 x plus our error or residual. So that's the general model that we had. So, and then we said that when we want to find out beta null and beta 1. So for beta null and beta 1, we are going to find it as beta null estimate and beta 1 estimate. So I'm going to write down here beta null estimate and beta 1 estimate, right? And when we have something like this, it's like that we are going to have beta null estimate plus beta 1 estimate times x is going to be equal to the y estimate. So in fact, our y for the actual value for the y is equal to our predicted value, which is the result of our regression model, plus the residual, right? So now we found that, and then we said that, okay, we're going to find out beta null and beta 1. There are like 2 videos that we worked on this one, that how can we find this. After finding any parameter, whether it's like we are talking with betas or we are talking about, let's say, mean or variance, all of these ones, what we need to do is that we need to do some tests on them, or we need to find out the confidence interval for that one. Because be careful, all of these estimates are for the samples, and we want to know that we have our population, so we are going to get the sample, find out some estimates based on those samples. Then we want to generalize that. We want to say that, okay, is it going to work for our population or not? So with the hypothesis test, the first step was that what's the parameter of interest? Here, let's work on beta null, right? So I would say my parameter of interest, so step number 1 is beta null. The parameter of interest for me here is beta null. The second step is that we want to test the null hypothesis and alternative. Write down the null and alternative hypothesis. So what I'm going to do, the second step, I would say the null hypothesis, this one was, okay, so the null hypothesis, my beta null is equal. So we said that for the null hypothesis we have the equality sign. So I would say my beta null is equal to beta null null, and the second null is the one, it says that, for example, whatever you have for your expectation, right? And then the alternative hypothesis, it's going to be that my beta null is not equal to the beta null. No. So that's going to be my null and alternative hypothesis. Then it says that, okay, find out your alpha. So depend, 4 is the step 4. Is that alpha? So most of the time we assume that alpha is 5% and we are working with a 95% confidence interval. But depending on the different situation that we have, it can be like something else. Like if you have 99% confidence interval, our alpha is going to be 1%. So here, let's say we assume our alpha is equal to the 5%. And then in the next one is test statistic. Test statistic, we said that whenever we work with test statistic, we want to find out the amount of this, we need to see that what's our parameter of interest. For example, when our parameter of interest was mean and we knew the variance, right, variance of the population, our test statistic was x bar minus mu divided by the standard error of it. So, and it was z in that case. For this one, when the parameter of interest is beta null, my test statistic, first of all, we are going to work with t-table. So it's going to be t null, right? And the general form for the test statistic is that we say that it's equal to the whatever estimate that you have. Like for example, when you say x bar minus mu, x bar is your estimate, right? So here for beta null, it's going to be beta null estimate, right? Minus, over there we said x bar minus mu, so it's like that. What's going to be your, instead of mu, here our parameter of interest is beta null, right? And we said that the one that is we are expecting to have it is like beta null null, so it's going to be beta null null. So it's going to be beta estimate minus this one. And then here we would need to have the standard error of the parameter of interest. So we said that we are going to have the divided by the standard error of the parameter of interest that we have. So a standard error here for the beta null estimate is going to be, if you go back to the previous video when we talked about the sum of a square of regression analysis, we talked about the amount of the variance that we would have for the beta null. So the standard error here is going to be a square root of that, right? So I would write down a square root of the sigma 2 and then 1 over n plus x bar power 2 over s xs. So this one is my standard error for the beta null estimate. So I would say this, the whole denominator here, in fact, it's my standard error of the beta null estimate. In fact, it's like that, your estimation minus the parameter of interest divided by the standard error of your estimation of beta null estimate. Okay, so we have the 5 here is that we want to, which was the test statistic. The next one is the rejection region. So we want to know that in what cases we are going to reject our null hypothesis, right? So for this, when we are talking about the rejection region, I'm just going to draw something here as a quick reminder. So we said that if this one is my t-table, let's say if this one, my Tn is normally distributed, so if I have my value here, my rejection region is going to be this area and this area, right? So here is going to be null hypothesis. These two areas is going to be in the area of the alternative hypothesis. In fact, if I have the if I have my t null value, which comes from the sample, greater than this number, right? T from the table. These t and these t, we read them from the table. It's based on the alpha that we have and the degree of freedom. In that case, we would say that we are in the rejection region. So here I would say 6. For the rejection, I would say if my T null, right, the absolute value of it, it's greater than the T half of the alpha, if it's two-sided, half of the alpha, and then n minus 2. So the degree of freedom here is n minus 2 because we have beta null and beta 1. So that's the rejection region. And then we would, in the next one, we do all the computation. It means that we are going to find out all the calculation, whatever it is. And then in the last step, we are going to find out the value for the, like we would say that what would be the conclusion. Meaning that if my T null was greater than this value comes from the table. If this one was greater than this one, then I would say that I'm gonna, I'm in the rejection criteria, so I reject the null hypothesis. If it was less than, I would fail to reject the null hypothesis. So I can write it down the conclusion like this. If the absolute value of the T null, which comes from the test statistic, is greater than T from the table, which is T half of the alpha and the n minus 2, then I would reject the null hypothesis. Okay? If this one, like T null, was less than T half of the alpha at half of the alpha and n minus 2, then I would fail to reject null hypothesis, which is this one. Okay, so this is for the beta null. The next thing that we want to work on is that what's going to happen for the beta 1. I'm going to quickly say that here because it's very similar. So when we are talking about the beta 1 here, what's going to happen? First of all, my parameter of interest, I would recommend that you pause the video here and try to write down the steps for the beta 1 estimate, and then come back and watch the rest of it. So my parameter of interest is beta 1, right? My null hypothesis is going to be my beta 1 is equal to beta 1 null, like the one that I have for the from my catalog. And then 3, alternative hypothesis, this beta 1 is not equal to the beta 1 null. Alpha is the same. We are going to make some assumption. Assume like alpha is equal to 0.5 if we didn't have any value for the alpha. And then is the test statistic. So test statistic again is different here because the standard error of the beta 1 is different. If you look at the variance of beta 1 in the video that we had about the sum of a square of the regression analysis, you can find out, you can see the variance of it. So for 5, for test statistic, again is going to be t-table. Like it's going to be related to the t-table, so it's going to be t-test. So our T null is going to be equal to the beta 1 estimate minus beta 1 null divided by the standard error. A standard error here, it's simple. It's a square root of the sigma 2 over S sum of a square of xs. For all of these ones, if we don't know the variance, we can use the estimate of it. For example, I can write down the estimate of the sigma 2. Here I can write down the estimate. It's the same. It's going to be the same. And then I'm going to write down my rejection criteria for rejection region. So for the rejection region, I would say that if my T null is exactly the same as this one, actually. So it's the absolute value of the T null. It's greater than T half of the alpha and n minus 2. And we read this from the table. This one is coming from the alpha, and in fact it's with the this one is coming from the sample, this one is coming from the table. So it's like that, whatever the sample size that you have on alpha, it's going to make a decision on this one. Okay, so this is 6. 7 is going to be, again, the calculation. Like you're going to find out all of these value and put it. And 8 is going to be the conclusion. Okay, so we talked about the beta 1 and beta null, right? I didn't write down the conclusion of this one because it's exactly the same as this. We have another category as well. So we find out the beta null and beta 1. And that category is that when beta, we want to make sure that our beta 1 is not equal to 0. This one is very important. So here my parameter of interest was beta null. Here my parameter of interest is beta 1. The next one is that when my parameter of interest is beta 1, but in that case, I want to make sure that the beta 1 is not equal to 0. Because if beta 1 is equal to 0, it's going to, in fact, my model wouldn't depend on the x, right? So the next one is that when we call it significance of regression. So it's the category, like the third part, and we are talking about the beta 1, and it's the time that we want to make sure that to see that if my beta 1 is equal to 0 as a null hypothesis and beta 1 is not equal to 0 as alternative hypothesis. So that's another one. I'm going to talk about it in another video. We use ANOVA table for this one, and you can see in the next video, which is about this one, and I'm going to talk about that in detail.